Go ahead and get started. Again, last time we were working on arc length. And to remind you of the formula, there's two formulas you're going to need to know for this section. They're very straightforward. Arc length is equal to the integral from a to b of the square root of 1 plus the derivative of whatever function you're trying to find the arc length of, squared dx. Or arc length would be equal to the integral from c to d of the square root of 1 plus the derivative of the y function squared dy. So in each one of these problems, you're going to be given a function, y equals f of x or x equals f of y, and you're going to be given some type of bounds. And the bounds will be between a and b for x and maybe c to d for y or whatever. And you're going to be finding the arc length. But as I mentioned to you guys before, here's your problem. We're going to give you a function. To actually find the arc length of this dude, you got to go back to calculus 1 and take its derivative. Okay? And you plug that derivative into this formula. You're going to take that derivative, you're going to square it. Okay? And that means you got to clean that thing up. Then you're going to add 1 to it, clean it up some more, and then take the square root of that and integrate the square root of this awful nasty looking function. You with me? Now for the most part, this doesn't take much to get a very convoluted kind of a problem to be able to integrate. It's not going to be a U substitution, integration by parts, all those interesting techniques typically won't work. You'll try to have some kind of numerical method for some of that stuff. However, there's a few problems out there that we work real hard to create for you guys that works very well, that when I take the derivative, I plug it in here, I square it, I add 1, and then you can clean that up and it will factor perfectly to kill off the square root so you can actually integrate the thing relatively nicely. So pay attention to some of these problems, but trust me, in the scheme of life, these problems are not typically what you run across. Most problems are going to be nasty, 99.9% of them. These are the ones that 0.1% that work out very nicely in these formulas. So let's go ahead and get started here. Pick it up where we left off last time, and here's my arc length formula, and here's my first problem. It says this: find the arc length of x equals y to the 3/2 power between y equals 0 and y equals 1. This function is a function in terms of y. So between these two formulas, I'm going to use the second one. Because it's in terms of y, I'm going to use the dy formula. So I've got x is equal to y to the 3/2 power. That implies x prime is going to be the derivative, which is 3/2 y to the subtract 1, negative 1/2 power. Positive, excuse me, I can do math. Positive 1/2 power. 3/2 minus 1 is a positive 1/2. So when I plug it into this formula, arc length will be equal to the integral of the square root of 1 plus my derivative, which is 3/2 y to the positive 1/2 power, squared dy, and they tell me what the bounds are, between 0 and 1. Now the goal here is to integrate this thing, but before you integrate it, you got to clean it up. This was my derivative of my function. The derivative of y to the 3/2 is 3/2 y to the 1/2, and I plug that right in here, and I'm going to clean it up. Now this one's nice because it's strict multiplication division, so I can distribute my power. So it would turn into the integral from 0 to 1 and the square root of 1 plus 3 squared is 9, 2 squared is 4. However, what is y to the 1/2 squared? Power to a power, what do you do with the powers? You multiply. That'll give you y, dy. Does that make sense? Now, if I was going to integrate this thing by hand, because you need some practice on this stuff, what technique of integration would you use? U substitution. Using U substitution, U would be equal to inside the parentheses, 1 plus 9/4 y. That makes du equal to my derivative. The derivative of 9/4 y is going to, 1 plus 9/4 y is going to be 9/4 dy. I'm going to move my constant to the other side, so 4/9 du is equal to dy. I multiply both sides by 4/9. So when I substitute, this will turn into the integral of u, but I don't do square roots. A square root is a 1/2 power, du. Integrating this guy, add 1 over add 1, that'll be u to the 3/2 over 3/2. I'm going to clean it up. That becomes 2/3 u to the 3/2, and then I'm going to back substitute. This will be 2/3 of u, but u was 1 plus 9/4y to the 3/2. So all this work is just integrating this guy. And this one wasn't too bad. So this is equal to 2/3, 1 plus 9/4y raised to the 3/2 power, and then bracket from 0 to 1. No plus c's because I got bounds from 0 to 1. According to the fundamental theorem of calculus, we will plug in top number minus plug in bottom number so we can evaluate this here definite integral. So plugging in top, that'll be 2/3 times 1 plus 9/4 times 1. Minus plug in bottom, 2/3 times 1 plus 9/4 times 0. Oh, I forgot my little 3/2 power. Raised to the 3/2 power. So I'm going to clean these guys up. This is equal to 2/3 times, well, 9/4 times 1 is 9/4. 9/4 plus 1, 1 is 4/4. That would make it 13/4. Raised to the 3/2 power, minus 2/3 times, 9/4 times 0 is 0. 0 plus 1 is 1 to the 3/2 power. And 1 to the 3/2 power is nothing but 1. So we'll end up getting the answer 2/3 times 13/4 to the 3/2 power minus 2/3. Does that make sense? Now, I'm sorry, but, this is, I can't make these answers that much nice. It was nice we could integrate it. I didn't promise you anything about the answers. So I'm going to actually just go ahead and stick that on the handy-dandy calculator here. The answer is 2/3 times 13 divided by 4 to the 3/2 power, right, minus 2/3, and I end up getting this number here, okay? And I get 3.23, let's see here, whoops, oh, I forgot one thing, my fault here, hold on, go back and double check my integration here. U du, this is u, and then 2/3, and I left my constant out front, didn't I? I forgot my constant, 4/9. Oh, this will be times 4/9, and 4/9 times 2/3 makes it 8/27, and that will be my constant. So when I integrate, this will be 8/27. This was my fault. I'll plug in 8/27 because I left off my constant. 8/27, and 8/27, and 8/27, and 8/27. So let's try this again. I left off my, from my du, my 4/9 du, my constant out front. So I had to go back and put my constant out front over here. So that'll be times at 4/9. That's where the 8/27 is coming from. So making that constant over here, just to make him nice and make it look exactly what I typed in. The new coefficient up front was actually 8/27. And I end up getting the answer 1.4397, so that is 1.439709873. And what kind of units would I put on this thing? Units. This is arc length. Units squared is area. Units cubed is volume. Units is just length. This is units. With all integration, you should always do this. Now, if you got access to a 21st century style calculator, you may want to just, because certain problems are going to make you show your work. And I showed my work, and if I wasn't paying attention, I would have actually lost out on my constant. So the last thing I want to do is just to make sure this thing's going to work, I'm going to put it on my old kind of handy-dandy calculator. So math number 9, integral from 0 to 1 of that square root of 1 plus 9x, insert that die again, x divided by 4 dx. When you use the calculator, the x variable is so much easier to type in than the y variable here. So I'm literally just typing in the original question before I did all that u substitution stuff. And let's see, oh, there it is, 1.4397007. Yeah, I'm feeling good about my answer now. Double check your work. We all make careless errors, especially when you're rushing through stuff, but you can't afford to make a careless error, so go back and double check your work and stuff, okay? And so watch that extra constant being put out front and don't forget to multiply them through. Does that make sense? Questions? This one wasn't too bad. This one, I mentioned to you guys about quote unquote, in web work, they're going to do some very special problems. Here is one of these very special problems that web work has set up for you guys. Because this thing looks absolutely nasty. Let's read the problem here. It says this. Find the arc length of the function f of x equals x squared divided by 2 minus natural log of x over 4 between x equals 2 and x equals 4. First things first. It says arc length, you got to know your formula. And you got to know which formula to use. This formula, because this is a function in terms of x, is going to be the integral from a to b of the square root of 1 plus the derivative of my function squared dx. Okay? Now, what's my derivative? Well, my function here, I'm going to clean them up. This is 1/2 the x squared minus 1/4 the natural log of x. So when I take its derivative, the derivative of 1/2 x squared, well, derivative of x squared is 2x. 2 times 1/2 is 1. That just gives you pretty much 1x minus 1 over 4 times, and this is for your benefit, hold that constant out front. What's the derivative of the natural log of x? 1 over x. So this gives you, when you clean them up, is x minus 1 over 4x. That is my derivative. Does that make sense? Plugging them into my arc length. So my arc length would be equal to the integral of the square root of 1 plus x minus 1 over 4x quantity squared dx between your bounds, between a and b, which is from 2 to 4, as those were given to me. Does that make sense? Now, in this problem, we're going to tell you to integrate it by hand. On web work, you know it's going to be one of these special problems when they're going to do something, and I'll show you later, the square root of g of x squared after you clean it up. They want you to type it in, what it's supposed to look like. This thing cleans up nicely. Usually I would just have to go, man, this is a nasty function, I'm going to say, and set up the integral and use your calculator to integrate. But this one, we can clean it up. To clean it up, you first have to clean up this x minus 1 over 4x squared. Now, x minus 1 over 4x squared, by definition, means it's x minus 1 over 4x times x minus 1 over 4x. And to clean that guy up, what do I have to do? Distribute, FOIL it out. So you're going to clean it up by FOILing it out. X times x is x squared. X times 1 over 4x is what? What's x times a negative 1 over 4x? The x's cancel, you're left with the minus 1 over 4. Does that make sense? The inner, negative 1 over 4x times x is going to be a negative, another 1 over 4, because the x's cancel. But last, negative 1 over 4x times negative 1 over 4x is plus, negative times negative positive, 1 over 4 times 4 is 16, x times x is x squared. I folded it out. I'm doing the algebra. But what's a quarter minus a quarter? What's a negative a quarter minus another quarter? Minus 1/4 is a minus 1/2 plus 1 over 16x squared. That's cleaned up. Does that make sense? And that's what I get to plug in right in here. So my arc length would be equal to the integral from 2 to 4 of the square root of 1 plus x squared minus 1/2 plus 1 over 16x squared dx. Clean it up. You can combine like terms. So combining like terms, I get this. 1 minus 1/2 is how much? Plus 1/2. So this turns into, arc length would be equal to the integral from 2 to 4 of the square root of x squared plus 1/2 plus 1 over 16x squared dx. Geez, Dr. Taylor, that doesn't look any better than what we started with. Wait. Your problem with integrating this guy with the arc length formula is that crappy big old square root. That's that part of the formula. It's the square root of 1 plus derivative squared. So you got to clean up that square root. Watch what happens. This thing actually factors perfectly. Let me show you. This will be equal to the integral from 2 to 4 of the square root of, watch it factor. What times what is x squared? It's x times x. What times what is 1 over 16x squared? 1 over 4x times 1 over 4x. Now, how do I get my middle term out of this? When they're plus on the classic anti-foiling stuff, they're going to be plus. And watch happens. Watch what happens. The fact is, the middle term ends up becoming a plus a half. Let me show you. To get the middle term, you got to do the outer inner on the FOIL. X times 1 over 4x is 1/4. 1 over 4x times x is another 1/4. So the outer inner each give you a fourth and a fourth. A fourth plus a fourth makes it 1/2. And so this is dx here, and this is a perfect square, so this turns into the integral from 2 to 4 of the square root of x plus 1 over 4x squared dx. And now, what happens to the square and the square root in this mathematically magical problem that you have here? They cancel, and it turns into something you can actually integrate by hand. The integral from 2 to 4 of x plus 1 over 4x dx. So integrating it, integral of x is x squared over 2 plus 1/4 is a constant. Leave them as 1/4. What is the integral of 1 over x? That one you're supposed to know. What's the integral of 1 over x? Natural log, officially absolute value of x, evaluated from your bounds from 2 to 4. So, according to the fundamental theorem of calculus, we shall plug in top minus plug in bottom. This will be equal to 4 squared divided by 2 plus 1/4 the natural log of 4 minus 2 squared divided by 2 plus 1/4 the natural log of 2. Again, I don't say the answer is going to be nice, but you can at least clean this guy up. 4 squared is 16. 16 divided by 2 is 8 plus 1/4 the natural log of 4 minus 2 squared is 4 divided by 2 is 2 plus 1/4 the natural log of 2. That negative is going to distribute, so this is 8 plus 1/4 the natural log of 4 minus 2 minus 1/4 the natural log of 2. And combining like terms, 8 minus 2 is 6 plus 1/4 the natural log of 4 minus 1/4 the natural log of 2. And that is my answer. Does that make sense? So again, it is 6 plus 1/4 the natural log of 4 minus 1/4 the natural log of 2 when you combine like terms. And you can put it on your calculator and check the decimal on it. WebWork will take it either way. But I warned you guys, WebWork likes these special problems that cleans up the square root on the ArcLink formula, but those are incredibly rare. So let's take a look at this next guy. This is more like the kind of a problem you're going to encounter if it's just a traditional WebWork problem. Set up the integral and use your calculator to integrate because the integral is actually rather nasty. So here it is. Set up the integral that will calculate the arc length of y equals the cosine of x on 0 is less than or equal to x, which is less than or equal to 2 pi. And use your calculator to evaluate. So here we go. My function is in terms of x. So this is my formula. The arc length is equal to the integral from a to b of the square root of 1 plus the derivative of my function squared dx. This would be the integral from 0 to 2 pi of the square root of 1 plus my derivative. If y equals the cosine of x, what's y prime equal to? What's the derivative of cosine of x? Think derivative, not integral now. What's the derivative of cosine of x? Negative sine of x. So this would be negative sine of x squared dx. Now this is for multiple choice of a test or final exam kind of a question. Traditionally, we would not leave this as such. On a multiple choice question, we would have cleaned it up and said the answer is going to be the integral from 0 to 2 pi of the square root of 1 plus, what is a negative squared? Positive, so you can drop the negative there. And we would write it as sine squared x dx, and that would be the answer on the multiple choice question. But on this particular problem, okay, I want you to actually use your calculator to evaluate it. Now, it's a real shame if you're this level of math and can't get your calculator to get you the right answer. So I want everybody right now to to actually grab your calculator and put this thing on your calculator to actually integrate it. Because I'm going to show you something, brother. Because I got a feeling somebody's in here is going to mess this problem up. So let's do it. All right, so I'm going to do math, number 9, function integrate, using my TI-84 plus calculator here. My bounds are between 0 and 2 pi of the square root of, and I type it in on my calculator exactly the way the formula is, just to make sure I didn't make a careless error if I'm going for that calculator answer. So it'll be square root of 1 plus parentheses, the negative, the sine of x, close parentheses there, but then you got to close parentheses for that negative sine of x because it's got to be squared, and then over arrow dx. So this is how I typed it into my calculator. Now everybody double check this thing and be honest with me. I'm going to hit enter, and then it's going to give me an answer. What did I get? I got 7.640395578 units because it's arc length. And somebody here didn't get that answer, I promise you, because I've seen it on the test too many times. And they did everything what I did. All right, we got one up here just helping them push the buttons on the calculator. That's a different story. But who didn't get the answer? Raise your hand. Be honest with me. Who didn't get the answer in here? All right. You know why you didn't get the answer? It's in the wrong mode. Check your mode. We're in math class. You should always be in radians. But I know some of you guys are taking physics and you guys are doing some interesting pitch off of a roof or some inclined plane. And in physics, they just love degrees and it'll be a 30-degree angle. And you got to be in degree mode on a physics class when they're doing those kind of problems. That's great. But in a math class, you should always be in radians based upon that pi concept. 0 to 2 pi. You know this thing's in radians. You got to be in radians because if your calculator's in degree mode, I don't care what you type into this thing in terms of these sine, cosine, tangent, you'll never get the right answer because it's the wrong mode. Double check your mode before you go any test or final exam in a math class. All right. Does that make sense, though? The wrong mode is typically the problem. All right. Here is that web work problem I was telling you about. And this is the way it's going to look when you know it's one of these been worked out before you because it's supposed to be, quote, unquote, a very nice problem. This is the way web work sets it up because you got to type in these particular parts here. It says this. Consider the curve defined by y equals x to the 8th divided by 12 plus 1 over 16 x to the 6th from x equals 2 to x equals 4. And then you're supposed to, okay, that functions in terms of x, and they, Merry Christmas, they actually gave you what the formula is. That's rare. You're supposed to actually memorize this thing. It's the integral from 2 to 4 of the square root of 1 plus the derivative squared dx. Where's the derivative? So my first step is I got to find my derivative. So y equals x to the 8th over 12 plus 1 over 16x to the 6th. But before you take a derivative, you got to clean them up. So this is actually 1 over 12 x to the 8th plus 1 over 16x to the negative 6. I don't like stuff on the bottom when it's got a power. I want to bring it to the numerator and make the exponent negative. Now, take the derivative. Y prime will be equal to, well, 1/12 is a constant, leave it alone. The derivative of x to the 8th is 8x to the 7th plus 1/16 is a constant. Derivative of x to the negative 6 is going to be negative 6x to the subtract 1, negative 7. And then I'm going to clean them up. So y prime equals 8 divided by 12 is what? Let's see here. 4 goes into both of them. So 4 goes into 8 2 times. 4 goes into 12 3 times. So it's 2/3 x to the 7th. A positive times a negative is a negative. 6 divided by 16 factors by 2. So that'll be 2 over 8 x to the negative 7. There is my derivative, and that's what goes here. 2/3 x to the 7th minus 2/8 x to the negative 7th. Does that make sense? Basic Calc 1 stuff. But now, look what they state. This is how you know it's one of these, oh, I won't be using the calculator to integrate this thing. I'll have to do it by hand because it's going to clean up nicely. Then they say this, simplify and factor to get the integral from 2 to 4 of the square root of this g of x squared dx. So the square and the square root cancel, and then you got to tell me what you're basically integrating here. That square and square root cancel is that very rare thing. So let's go over here and type it in. So this becomes the integral from 2 to 4 of the square root of 1 plus my derivative squared dx. That'll be the integral from 2 to 4 of the square root of 1 plus my derivative is 2/3 x to the 7th minus 2/8 x to the negative 7th squared dx. So what I'm talking about here is cleaning up inside this parentheses. But notice, this 2/3 x to the 7th minus 2/8 x to the negative 7th, kind of lost them there, x to the negative 7th, squared is the same thing as 2/3 x to the 7th minus 2/8 x to the negative 7 times 2/3 x to the 7th minus 2/8 x to the negative 7. And you're going to FOIL it out to clean it up. And just what happened in that last problem is going to be the same thing. Question?
It should be
Negative? Oh, did I screw up here? Hold on. Yeah. 16 divided by 6, 2 goes into it. You're right. 3 times. Thank you. Having a bad day today. 3/8. Thank you. That becomes 3/8. So make this 3/8 up here. If you're going to do it right. 3/8. This is 3/8. 3/8. And I would have discovered that. Thank you for letting me know, because I would have discovered that in about 30 seconds from now. All right, so, because what's going to happen here is this thing's going to clean up here. So it's 3/8. So now, there's a pattern here, and you tend to get the same stuff. So watch what happens. I'm checking for patterns here. So folding this thing out, like you said, negative 6 over 16 is actually 3/8. 2 divides into 6 3 times, and 2 divides into 8, so 2 divides into 16 8 times. There you go. So folding this thing out, 2/3 x to the 7th times 2/3 x to the 7th is 4/9 x to the 14th. You with me? 2/3 times, here it comes, x to the 7th times a negative 3/8 x to the negative 7th is what? Well, the 3's cancel, right? And 2 goes into 8 how many times? 4 times. So that's going to give you a negative 1/4. Now let's both multiply your variables. What's x to the 7th times x to the negative 7th? When you multiply, you add exponents. 7 plus negative 7 is 0, and anything to the 0 power is 1. The variables cancel out. Does that make sense? And you just get 1/4. And then when you do this again on the inner, negative 2, so it's negative 3, negative 3/8 times a positive 2/3. The 3's cancel. 2 goes into 8 4 times. And so you get another negative 1/4, and x to the 7th and x to the negative 7th end up canceling, x to the 0. And then you've got to do the last. Negative 3/8 times a negative 3/8 is going to be a positive 9/64. But what's x to the negative 7 times x to the negative 7 would be x to the negative 14, because when you multiply, you add exponents. I fold this thing out. But what happened to that middle term? And there's going to be your trick right there. They end up canceling and give you a constant. And not just any constant. What does it give you? It's equal to 4/9 x to the 14th minus 1/2, minus the 4th, so minus half, plus 9/64 x to the negative 14. And I'm going to plug that right in for my cleaned up version of this guy. So this ends up becoming the integral of the square root, integral from 2 to 4, of the square root of 1 plus, this is my fold out squared thing here, 4/9 x to the 14th minus 1/2 plus 9/64 x to the negative 14 dx. And combining like terms, you've seen this before. What is a 1 minus 1/2? It becomes plus 1/2. So this is integral from 2 to 4 of the square root of 4/9 x to the 14th plus 1/2 plus 9/64 x to the negative 14th dx. And just like it happened in that last problem that we did, what's underneath your square root is going to factor. And they've already told you with that square root of g of x squared thing, it's going to factor perfectly. How does 4/9 x to the 14th plus 1/2 plus 9/64 x to the negative 14th factor? Well, what times what is 4/9? 2/3, 2/3. What times what is x to the 14th? X to the 7th, x to the 7th. What times what is 9/64? 3/8, 3/8. And what times what is x to the negative 14th? That'll be x to the negative 7th, x to the negative 7th. And what do my signs have to be? Because they're both plus and it's a quadratic style, they're both going to be pluses. So this turns into the integral from 2 to 4 of the square root of 2/3 x to the 7th plus 3/8 x to the negative 7th squared dx. Does that make sense? And what does the square and the square root do to each other? Cancel out. So this turns into the integral from 2 to 4 of 2/3 x to the 7th plus 3/8 x to the negative 7th dx. Now to answer the question, back up here. In terms of the square root of g of x squared, the square and the square root cancel. So what did your problem turn into? You're going to be integrating what? The answer that goes in this blank is 2/3 x to the 7th plus 3/8 x to the negative 7th. And you should be catching patterns on these kind of problems, because with these kind of problems, look at the answer in this blank and the answer in this blank. What ended up happening? You change your sign. So therefore, the famous cut, copy, paste will be always advantageous on a problem like this. And just change your sign on. But here's the work involved. But now the last thing you're supposed to do is actually figure out what the arc length is. So we need to integrate this guy. So this is equal to, now 2/3 is a constant. Integral x to the 7th is x to the 8th over 8 plus 3/8 integral x to the negative 7, add 1 will be x to the negative 6 over negative 6. So cleaning that up down here at the bottom of the page here. Let's see, 2 goes in 8. Make sure I don't screw my arithmetic up this time. 2 goes in 8 4 times, and 4 times 3 is 12. So this is x to the 8th divided by 12. A positive times a negative is going to be a negative. 3 goes into 6 2 times, and 2 times 8 is 16. So that becomes x to the negative 6 over 16, evaluated from 2 to 4. Does that make sense? And so now, fundamental theorem, plug in top minus plug in bottom. That'll be 4 to the 8th over 12 minus 4 to the negative 6 over 16 minus plugging in 2 to the 8th over 12 minus 2 to the negative 6 over 16. And I never said the answer is going to be, quote, nice, but the integration cleaned up nicely. So I am going to go do it on the old handy dandy calculator here. And plugging in on my calculator so you guys can see this thing. Here it is. It is 4, put parentheses around it, parentheses, 4 to the 8th divided by 8, divided by 12, excuse me, divided by 12, minus 4 to the negative 6 divided by, whoops, over error there, divided by 16, close parentheses, minus, make it look exactly like I'm typing in and don't screw it up, parentheses, 2 to the 8th divided by 12, minus 2 to the negative 6 divided by 16, close parentheses, enter, and I get some crappy answer, 5,440.000961, what? Units, because you're finding the length of the interesting curve that we were playing with. Does that make sense? Didn't say these problems are trivial, but they're more anything. They're not overly difficult once you understand the pattern, but they are incredibly tedious in terms of the parts you have to do on this thing. All right, one more problem from section 7.4, and then we'll move on into section 7.5. 7.6, actually. Here it is. This is another web work problem. So you got to analyze this thing. So a hawk flying at 18 miles per second at an altitude of 120 meters accidentally drops its prey. A parabolic trajectory of the following prey is described by the equation. Oh, I got an equation. Better write that down. Y equals 120 minus x squared over 54 until it hits the ground, where y is the height above the ground and x is the horizontal distance traveled in meters. The distance traveled by a prey is equal to d Let D be the distance traveled by the tray, time dropped until it hit the ground, and that's what we're supposed to find, the distance it hit the ground. So what you need to do here is this. Let's just graph this equation so you guys would understand what's going on here. So I got 120 minus x squared divided by 54. Now, I'm going to do a zoom 6 on this thing, but if I do a zoom 6, negative 10 by 10, oh, got error message here, y equals, oh, little minus sign back there from the last problem. If I do a zoom 6 on this thing, basically I won't see squat on terms of this graph. You know why? Number one, the graph is off the page up here. Y equals 120, so it's already up here at the top and stuff like that. But you also have to pay attention to what x is going to be. X represents the distance in meters the prey fell. So all we're trying to do is, we're going this time, and right at x equals 0, this hawk has this prey, and somehow it wiggled out of its claws, and it's going to be coming down. But because of that forward trajectory and due to gravity, this thing's going to have this forward trajectory. So I'm going to go to y equals 0, and how far do you think this prey is going to fall? Well, I think it's going to fall probably around at least, 50 feet or something like that. So I'll do 50, and then I'm going to do a zoom fit, zoom number 10, there, zoom fit, and it takes my x's and it actually shows me what the thing's going to do. And there it is. And I'm going to change it just a little bit so you guys can see it. So let's make it 60, because I want you guys to actually see that the graph is coming in, and boom, it hits the ground right there. Does that make sense? So, we want to figure out the length of the curve. So you understand, you've got a hawk flying, and he's flying at a rate of 18 meters per second at an altitude of 120 meters. And then he accidentally, of course, drops his prey. And it's coming down here. And we want to find this arc length. So remember, arc length is equal to the integral from a to b of the square root of 1 plus my derivative squared dx. I've got to have a couple of things on this problem. First thing I need to do is, this is the equation of the path of the prey. I need its derivative. No problem there. Derivative of 120 is 0, minus 1 over 54 is a constant, even if it's on the bottom. Pull him out front. Derivative of x squared is 2x. I can clean that up. So y prime equals negative. 2 divides into 54. 54 divided by 2 is 27. This is 1 over x divided by 27 when you clean them up. There's my derivative. So my arc length would be equal to the integral of the square root of 1 plus negative x over 27 squared dx. Does that make sense? What's missing in terms of this formula? Because I've got it. All I got to do is just crunch this thing out. The bounds. I got to figure out what the bounds are. Well, one bound is real obvious. When you look at the graph, the prey did this, right? X equals 0 is where we start. I got to figure out this point right here. How do I figure out what that point is? I'm going to take my equation, y equals 120 minus x squared over 54, and set it equal to 0, because 0 means he's hitting the ground. Does that make sense? 0 is ground level. I'm going to move this x squared over 54 to the other side, gives me 120 equals x squared over 54. I'm going to multiply both sides by 54. I get 120 times 54 equals 6,480 equals x squared. And then I take the square root of both sides. And the square root of 6,480 is 80.498444719. That's really when it, quote, hits the ground. Let me see here. Did I do something wrong here? 420 times 54. Yep. And then I had to take the square root of that. That's when it hits the ground. So that's going to be my x number. That'll be up here at 80 point, it's web work, so expect crappy numbers. 4984719. Now, here is the formula. Now, if you look at this thing, when you square this, you'll get an x squared over something or other. And to integrate this guy, honestly, you're going to have to, if you're going to do it by hand, you're going to have to go to your tables in the back of the book, because it's one of these square roots of a squared plus u squared looks. Sorry. So, but I'm going to use the calculator. So, it doesn't say not use the calculator. We just want to know the answer. So that'll be the math number 9, integral from 0 to this 80.498444719 of the square root of 1 plus my derivative, which is negative x divided by 27 squared dx. What path, how long did the prey go before it actually hit the ground? 151.0396416 watt. Very good. All this stuff was measured in meters. So understand what we got here. We got a nice little bunny rabbit grabbed by a hawk, flying along, and he's just squirming, all kinds of worried here, clearly. And then all of a sudden, he squirmed just enough that he got let loose. 120 meters above the ground. Okay? So even though he's 120 meters above the ground, he actually flew due to the force of the hawk flying at a horizontal distance horizontally at 18 meters per second. He actually flew 151.0396 meters until he hit the ground. I'm sorry. Okay. You understand? Yeah. And now the turkey vultures will come, but never mind. But does that make sense, though? The idea of the problem. Say you got a web work problem, looks just like it. All right, chapter 7.6. We skip over section 7.5, and we go into the 7.6 section out of our textbook, which is the concept of work. Hopefully you watched the awesome pre-section videos on this thing, but the idea behind work is very simple. Work is equal to force times distance. That's what you need to know. But when it comes to work, so now we're really getting into the physics concept of this class. Work is equal to force times distance. But you have, in this world, there are two different ways of actually calculating material. We have the English Standard way of calculating certain things like force and work and the distance and the like, and we also have the metric system in calculating work, force, and distance and the like. Because we live in the 21st century of a global economy, you're going to have to be familiar with both concepts of how to actually calculate units in those particular areas, whether it's the English Standard System or the metric system, okay? So, if I was working in the metric system, let's analyze force and let's analyze distance. In the metric system, distance is measured in what? Meters. Meters. That is my standard unit of length. So when you got centimeters, you got millimeters, you got kilometers, whatever, to standard unit, you're going to have to convert it to meters. The nice thing about the metric system is everything's based upon 10. So if I have like 10 centimeters, that would actually be 0.1 meters. You got to move your decimal place into the right spot. Does that make sense? Now, what is force measured in? Newtons. Now, force is equal to mass times acceleration. So you got Newton's second law playing on this part. Mass is measured in what? Mass, M. In the metric system, what is mass measured in? Kilograms. That is the standard unit for mass. You think kilo, that's 1,000 grams. Now, a gram, but it's so small, the standard unit for measuring mass is actually the kilogram. Okay? What is acceleration measured in? Acceleration is, it's the second derivative of position. That is going to be meters per second squared. Meters per second, meters per second squared. So, force is actually, when you put in your units, is going to be a kilogram times meter per second squared. Well, that's just too much stuff there. So the famous kilogram meter per second squared in the metric system is also known as a Newton. Yeah. You with me? Now, work is equal to force times distance. So the units you would have been expecting would be this. Force is measured in newtons. Distance is measured in meters, so the unit for work is the Newton meter. But who can we blame for the metric system? The French. Blame the French. What's the deal about the French? Well, number one, they can't win a world war without our help. Two, they love, oh, come on, we can pick on the French. They love their language and food more than anything else in this world. They love their language. And here's your problem with the Newton meter. Newton meter does not roll off the French tongue real well. So we have another unit for Newton meter. And it's all because it didn't sound good, they came up with another one. What is the Newton meter also known as? The joule. And so that sounds clearly so much better in the French language. So Newton meter, joule, same thing. Okay, so we call it a joule. Now, compare this to the English system. English system, numbers don't work out so well, but it's so much easier to use. So first thing here is you've got force times distance. The distance in the English system is measured in what? Distance. Standard unit is the foot. Okay? The force measured in the English system is measured in pounds. Now, you can go in there and talk about force is equal to mass times acceleration in the English system. The acceleration in the English system, actually, if you use gravity, is 32 feet per second squared. That's great. And it'll be feet per second squared. The problem is, what's the mass in the English system? Very few people actually know this. Do you know what the mass is measured in the English system is? It's called a slug. Yep, it's a slug. It's not just a thing that actually crawls around the ground there. It's actually the units that are used to measure mass in the English system, called a slug. So your slug times feet per second squared is actually what a pound is. We just say pound and don't worry about it, okay? So the nice thing about the English system is we actually don't actually go through the mass. We can if you want to, but we just say, how much does this darn thing weigh? And we tell you, 50 pounds. And we're good to go. We keep more with that. But in the metric system, they're going to ask you, what is the mass of your object? You've got to multiply it by gravity to actually get the force on said object. You're going to have to do more work in the metric system. But at the end of the day, we're interested in work. Work is equal to force times distance. Work is equal to, a force is equal to the pound. The distance that we measured in feet, it is the pound foot, but if we're going to run off the English tongue a little bit better, we'll take the French name out of it and we'll call it the foot pound. And that's the standard unit of length of work, standard unit for work in the English system, the foot pound, okay? So, if you come over here, and I did a bunch of problems for you guys on the pre-section video on this stuff to get this stuff down, okay? But this idea that I'm talking about is this whole idea behind work and the physics problems here and stuff. Other aspects, just going to go through this rather quickly, that you're going to need to know for this section. This section is quite large. We're going to take several days to go through this section because there's a lot of material in it. But in this section, we are going to have to come up with the equation of a line. Remember the famous point-slope equation. So if I ask you to find the equation of a line through a point, 2 points, 3, -2, and 4, 5, you've got to have the ability to do that. First thing you got to do is calculate the slope, change in y with the change in x. That'll be 5 minus -2 over 4 minus 3. That's equal to 7 over 1, which is 7. And then when you need an equation of a line, you're going to use the point-slope formula. Y minus y1 equals m times x minus x1. So y minus your y coordinate, pick a point, I'm going to pick -2, equals my slope times x minus my x coordinate 3. But traditionally, we like to solve for y on lines. So this is y plus 2 equals 7x minus 21. Subtract 2 from both sides. I get the answer y equals 7x minus 23. The other thing you're going to need to know is the famous equation of a circle. That is something you guys need to know. X minus h squared plus y minus k squared equals r squared. And so you got to talk about the center and the radius, but there you go. So in terms of these problems, let's just look at, I got 2 minutes left in class, or 1 minute now, according to the time. So people who are leaving, Joseph, take notes on people who are leaving, and we'll make sure that they don't get credit for being here. All right, so how much work is done in lifting a 60-pound object 3 meters up? How much work? Work is equal to force times distance. But here's your problem. They didn't give you force, they gave you mass. You got to go jump through another hoop. Force is equal to mass times acceleration. This is other things you need to know. Your mass is 60 kilograms. What is acceleration in the metric system? A number you're supposed to know. What is acceleration? Due to gravity. What is it? Very good. Things you need to know. 9.8 meters per second squared. So when you grab your handy dandy calculator, you got 60 times 9.8, and that gives you 588, and that would be a Newton. But wait, we're not done yet. That's just to get the force. You got to actually work with the mass to get the force by multiplied by gravity. The gravity in the metric system is 9.8 meters per second squared is what we'll use. So the work would be force times distance. That's 588 times, we're moving it 3 meters up. So that's your distance is 3. And so 588 times 3 is 1764. And we would accept Newton meters, but the traditional units is what? Joules. But notice how much work I had to do to get the answer for this work problem in the metric system. English system, same problem, just change it a little bit. How much work is done in lifting an object 60 pounds 5 feet up? Work is equal to force times distance. But in the English system, we just pretty much give you what you need. What was the force? That's measured in pounds, that would be 60 pounds. Times, what was the distance? Measure standard unit length of feet, 5 feet. And 60 times 5, I don't need a calculator for that. That's 300 what? Foot-pounds. Does that make sense? Our problem is going to occur when we start lifting stuff out of places. Because as you start lifting, the forces on objects begin to change. You know, how much, especially if you got an object that the mass changes as you lift it up or something like that. That's why the integral calculus is going to play a part. And we're going to see that next time when we do the famous Jessica problem. Study hard on this stuff, and I'll see you guys next time.